Hello, good afternoon. So I will be sharing my screen now. So good afternoon, everyone. So again, my name is Morris Bana, licensed professional teacher. Currently, I am a curriculum developer, curriculum and content developer for First EduSpec Inc. Incorporated. So my topic for today is all about Arduino and modern day teaching. So just a brief background about myself. So from 2014 to 2018, I have taught robotics. So I have been assigned uh, to two different schools. One in San Beda College, Alabang, and then the second one is in De La Salle University Integrated School in Laguna. So when I was still teaching, I am also a coach for the robotics team and also a master trainer. So dated back in 2018 to 2019, shifted career, uh, pero same company pa rin as a program manager and the chairman for the game design committee for the International Roboton. Philippine Roboton, and also a judge for the International Roboton. And was invited as well for different events as a speaker. And right now, ayun. So currently developing curriculum for Arduino. So my topic for today is all about modern day teaching. So Arduino and modern day teaching. So this Arduino day, uh, we started our session with the first speaker talking about AI, and up until our previous speaker uh, talks about the application of Arduino in drone technology. And some of you asked if pwede siyang gamitin for educational purposes. Now, this is the good thing about Arduino, that Arduino is flexible and it can be taught in schools. So, paano siya mangyayari, or what will be the para set of procedures and guidelines of applicating Arduino to the modern day teaching. So first, we have to define what is modern day teaching. When we say modern day teaching, we often come across with the word uh, the content and also the pedagogy. When we say content and when we say pedagogy, na nakalink kay modern day teaching, we talk about updating the current knowledge or the current set of content that is already on our DepEd curriculum, and also the ways of teaching it. So pedagogy. So we are moving away with the traditional teaching. We're in memorization and repetition is mostly prioritized. So those kinds of skill sets that we have, memorization, repetition, it's not actually promoting the 21st century skill. It is actually uh, moving away with the 21st century learning skills. When modern day teaching promotes is yung questioning, discussion among the students, collaboration between the students, and as well as demonstration. So in short, for modern day teaching, it is activity based. Okay, so we promote interactive learning. Okay, so interactive learning promotes critical thinking and as well as the 21st century learning skills. So when we say 21st century learning skills, so we have the 3 Ls. And under the 3 Ls, meron pa tayo mga subcategories. So we have the learning skill, we have the literacy skills, and we also have the life skills. So under the learning skills, we have the 4 Cs. So for the 4 Cs, we have the communication, creativity, we have the critical thinking, we have the collaboration. And for the literacy skills, we are having or promoting information literacy, media literacy, and technology literacy. And for the life skills, ito yung tinatawag nating FLIPS. So flexibility, leadership, initiative, productivity, and social skills. So those are the modern day teaching strategies that promotes 21st century learning skills. So yun yung target natin na matuto or ma-acquire ng mga bata. Once they exit the four corners of the school, they are already equipped with the 21st century learning skills. The question is how? One way of doing that is by integrating STEM education. So, yung STEM education actually nag-evolve na from time to time. So, from STEM, nagkaroon ng integration ng arts, naging STEAM education. And then comes robotics, naging STEAM education. So, these principles or philosophy integrates learning development. So, integration between science, technology, engineering, mathematics, robotics, and arts to the curriculum. Also, STEAM education promotes innovation and 21st century skill development. So again, it promotes interactiveness. Now, why do we need to do that? It's because we wanted our students to stay competitive in a changing job market. Okay? So again, sabi ko nga, once they exit schools, our school, we wanted them to be ready. They need to have the necessary skills, 21st century learning skills uh, for them to be ready for the future jobs. Bakit natin sinabi na changing job market? Actually, we are on the phase or at the beginning of the what we call the Industry 4.0 or the Fourth Industrial Revolution. So for the Fourth Industrial Revolution, ano nga ba siya? So Fourth Industrial Revolution is the Industry 4.0 refers to a new phase in the Industrial Revolution that focuses heavily on interconnectivity, automation, machine learning, and real-time data. So this is also sometimes called IIoT or Industry Internet of Things or Smart Manufacturing. So this coupled with physical production, with machine learning, the use of big data, digital technology, this will make the company or the ecosystem of the companies more holistic. So just our historical context, bakit natin sinabi na fourth industrial revolution, bakit siya fourth, hindi siya first, second, or third? Because for the first industrial revolution, it took place dated back on 18th century sa Britain, where the use of steam engine is used or discovered. And then comes second industrial revolution, the discovery of electricity. So we use oil, we use electric power for us to manufacture goods. Basically, the coming of the electricity further advanced the human civilization. So we have invented devices for communication, telephone, telegraphs, and so more. So pagdating naman ng third industrial revolution, so nag-evolve naman tayo. Okay, on the 20th century, we have completed or we have built computers na, and we have used computers for different things such as telecommunications, data analysis, for manufacturing processes, and dito na rin on the 20th century, we use the embedded programmable logic controllers. So ito na yung mga PLCs. Also the microcontrollers. Okay, so we use PLCs, microcontrollers to automate some processes and collect and share data. So pagdating sa fourth industrial revolution, so sa third may computer na, we have the internet, we have the sharing of information, we have data analysis. Ano na ma-offer ng fourth industrial revolution? So for the fourth industrial revolution, we advance further by using data analytics. We advance further when we have the internet connection, we have wireless connection naman, we have cloud computing, we have the Internet of Things, we have automation, we have artificial intelligence, we have the virtual reality, and we also have 3D printing. So in some cases, 3D printing is now in and also apply to different fields. Sa medicine, they are trying to and also pagdating naman sa architecture, in the field of architecture, the use of the principles of 3D printing a building, and with the use of other materials. So, according to World Economic Forum, we stand on the brink of technological revolution that will fundamentally alter the way we live, work, and relate to one another. So, it in the scale, scope, and complexity, this is unlike anything that we have experienced before. So, in response, it must be integrated and comprehensive. So, lahat ng stakeholders, kailangan involved for us to be prepared and move forward in the Industry 4.0 or the Fourth Industrial Revolution. So malaki yung factor or malaki yung uh, uh, contribution ng education sa ating Fourth Industrial Revolution because we needed the children, we needed our students to be prepared for the future jobs. Okay? And with that, meron tayong tinatawag na educational reform and we call it Education 4.0. So many of today's children will work in new job types that does not yet exist with an increased premium of both digital and social emotional skills in the coming years. So the gap between education and job is further widened by limited innovation. So we try to address that limited innovation in learning. So how do we address that? Access to remote learning. So the learning must be accessible kahit nasan ka man. Especially right now in the COVID season, uh, we try our best to make learning more accessible by doing online learning, modular learning, and different kinds of modalities. Also, educational tools. So our educational tools needs to be updated. Also, the practice of having project-based learning integrated in our curriculum, field-specific experience, and also processing of data. So data analysis, kailangan ma-practice ng mga bata yan. One way of doing that or when we say uh, how to implement education 4.0, one of the ways that we can do that is by the use of Arduino. So Arduino, a while ago, ang dami na discuss regarding with the applications of Arduino, starting from AI up until to the drone development. So here, we will talk about how do we integrate it to our curriculum. So we know that Arduino can yield multiple projects, uh, can be formed into different projects. Actually, ang limitation mo dito is yung creativity. Okay? Now, educational tool for Arduino is a platform for STEAM education, platform for project-based learning, platform for interactive learning, and an avenue for future-proofing. We teach them concepts, we teach them prototyping, we promote 21st century learning skills injected to the curriculum with the use of Arduino. And once the students mastered it and exit the four corners of the schools, they are ready. Also, with Arduino, we promote research-based output. So we have or we encourage the students to do more research on their output or to come up with an output based on a research. Also, this promotes citizen science. So later on, I will explain ano ba yung citizen science. So Arduino, as as an educational tool, we teach them what they can do with their knowledge. So the knowledge that we're talking about, not only yung knowledge na natutunan nila to how to program Arduino, but the integration with the other subjects. Usually, we use Arduino to be injected as a tool para dun sa lesson. So, the students will further understand the lesson because they know saan yung application nun. So, later on, I will present an example. So, with Arduino, plus a good sounding curriculum, kung maayos ang structure ng curriculum, it will yield to a better project, better output coming from the students. And having better output from the students promotes 21st century learning skills. Now, when we go about the structure of these three things, Arduino, curriculum, and the project, for Arduino, as a tool, we teach them the hardware and software basics. So we encourage engineering, we inject engineering concepts and also computer science concept into the curriculum or into the lessons. For the curriculum, the application of concepts. So sabi natin kanina, we have the STEAM education, we have the science, technology, engineering, mathematics, robotics and arts can be injected to this to Arduino. So application of context or the integration. Also, by developing a good assessment or challenges to the students, they'll be able to understand more ano ba yung tinuro sa amin and what's the purpose, how can it be applied to real life situations. Sunod doon yung processing of information. So for the projects, of course, we are producing students that is anchored in citizen science, and also their outputs are based on research. So for example, ito yung example ko. For example, I wanted to teach DHT11. So DHT11 is a temperature and humidity sensor. So being a teacher for around 4 years, and having been a program manager to FEI, I've been handling different schools. So I managed to get ano ba yung philosophy ng specific school na to, paano ba nila ginagawa yung integration, or what's their curriculum, what's their vision and mission of this different schools. And along that way, I picked up some things that right now I carry on as a curriculum developer. So ito yung practice ko when I create a curriculum for a certain course. I always make sure that the structure is good. Okay, when we say structure dun sa curriculum, yung fundamentals, hindi lang na yung magtuturo tayo. It's not that we are just teaching for them to learn how to code. They need to understand. They need to understand the science behind it. They need to understand the concept behind it, and as well as yung programming nun. So for example, DHT11, I know that this is a temperature and a humidity sensor. So when we talk about temperature, when I structured it, the first thing that I want the students to know is to recall or to know what is temperature. So they need to appreciate ano ba yung temperature. So dated back grade 5 up until their 12th grade, alam nila yung concept ng temperature. So you just have to reinforce the knowledge about temperature. And then once you have unlocked and reinforce yung concept ng temperature sa kanila, now you ask them, how do we measure temperature? Now, some of the students will say, we use temperature scales. So you discuss what are temperature scales from Kelvin, Celsius, Fahrenheit, paano ba siya? The physics of it, okay? Especially yung temperature. Temperature is a measurement of hotness and coldness. And then when you go to the molecular level, it is the movement of the atoms or movement of the molecules inside the movement of the atoms inside the molecules. And then next, devices that measures temperature. So introduce them. Ano-ano nga ba yung mga devices that measures temperature? So nandyan si thermometer and yung evolution nun. You can present them the evolution of it up until mag-lead na tayo sa mga digital temperatures. And then humidity. You discuss to them or you unlock the knowledge about what is humidity. And then how do we measure humidity? And then devices that measures humidity. And then after that, you integrated the two concepts, temperature and humidity. So the relationship of both. What's the relationship of temperature and humidity? Bakit yung air temperature ganito lang, let's say 28 degrees Celsius, pero bakit parang ang feel ko, I feel that this temperature is, let's say, 30 degrees or 35 degrees Celsius. So it has something to do with the heat index. Okay, so you introduce them another concept. So heat index, so what is heat index? How to calculate heat index. And then devices that measures heat index. So once a student have a solid background or the fundamental of the sensor that you're trying to teach to them, they have a better appreciation. Ano nga bang use niya? And then once you manage to do that, you teach them how to use that device na, how to use that sensor. So you introduce them what is DHT11. So it is a sensor that measures temperature and humidity. So para kapag alam nila yung, okay, nagme-measure siya ng temperature and humidity, temperature ganito, humidity ganito. So they have the better understanding. And then you teach them how does DHT11 measures temperature and humidity. Siyempre, some of the students especially have an advanced thinking na, okay, this device measures temperature and humidity, but how? How does it interact with temperature and humidity? So you discuss them that the HT11 is a thermistor. The sensor knows the temperature and the humidity because the resistance inside the sensor is changing depending on the temperature. And then you teach them the parts of DHT11, and then you teach them the pin outs or yung tinatawag natin saan ba siya i-connect. So usually this has 3 pins. And then once you manage to do that, you teach them a simple circuit prototype. So you teach them how to connect DHT11 to Arduino. So this is where the interfacing, this is where the demonstration, the guided learning comes into place. So you teach them, you show them how to do it, they let them do it, and then check if okay ba yung ginawa nila. Let the students commit mistakes. So for example, na-connect na nila and then along the way, sir, ma'am, ba't hindi po siya gumagana? So you ask them question, you do not give them the direct answer right away. You ask them, okay, did you connect it correctly? What is the correct pin outs or the pin connection? Something like that. So that the students would learn, okay, my mistake is this one, and on the upcoming activities, hindi ko na makakommit yung mistake na yun because I already know my previous mistakes. And then schematics of the prototype. So you discuss how to create a schematics of the prototype that you created so that they'll appreciate yung schematics or the blueprint of the sensor or of the prototype that you are creating. And then programming DHT11. So once you're done with the hardware, punta ka naman sa software. So na-master na nila yung connection sa DHT11 to Arduino, then you proceed with the programming. How to program it? So for example, adding of the DHT library, declaring of variables, the creation of variables that will be used. For DHT11, gumagawa pa tayo ng objects within the classes of the library. of the DHT11, setting the pin functionality. Is this an input? Is this an output? And then getting the reading coming from the DHT11. So you teach them how to do that. And then next, once they acquire the needed variables, for example, the humidity and of course the temperature, they'll be able to calculate the heat index na diniscuss mo previously. So they know how to calculate it, they will apply it na on the programming. So once you master that, you provide them challenges. So once the student knows how to program it, you give them a challenge. So for the challenge, for example, adding a push button in order for it to trigger the getting of reading and stopping the reading. Also, the application of LCD to display the reading. And then once the student uh, accomplish all the challenges, the performance tasks or transfer tasks that you provided to them, you process the information that you have uh, discussed to your students or the activity that you have asked the students to do. So you process it. So what are the uses and application of DHT11 sensors? So you ask them questions. And then after that, you have to, for example, transfer task pa lang yun. After you process it, you ask the student to do their performance task. Okay, for the performance task, for example, building an interface that uses DHT11 and other sensors. So you let them do their own projects na. So by doing this, you promote citizens science. So apply DHT11 in citizen science. So kanina pa natin discuss ano ba yung citizen science? When we say citizen science is a practice of public participation and collaboration in scientific research. To increase scientific knowledge, through citizen science, people share and contribute to data monitoring and collection programs. So we encourage our students to go out there and have your learnings apply to the world and contribute to the world. So we promote character development din sa students natin. Not only the 21st century learning skills, well, character development is under 21st century learning skills, but it goes beyond. Okay? One examples that I would share as a teacher way back in, I think, 2016 to 2018, we started to join competitions, uh, especially in innovations or in project-based competitions, wherein there's a specific problem that needs to be addressed, and we develop prototype to address that problem. So one example, siguro for me, my legacy, kumbaga, legacy as a teacher, na up until now, they're still doing this, or they are still continuing this project, is the project Aqualoop. So as mentioned a while ago, I am a contributor. Started as an entry to a competition, and the subject of that competition is Project Benham Rice. So how can we contribute to the scientific research dun sa Benham Rice? So this is our entry, so Aqualoops. So we develop an aquatic boy, a robotic boy. This is a multi-sensor boy that collects information. So yan yung unang itsura niya. So medyo bulky siya. That's our first competition, and we won. And then after that, we proceeded to compete for World Robotics Games. And the Aqualoop actually, it's a multiple entry eh. So it started at first as a competition entry, and then we got passionate about it. We joined multiple competition, not only yung mga robotics competition, but some of the competition that has causes, such as the Google Science Fair. So Aqualoop was listed for the regional qualifiers, and then the recently concluded 2019, I think, the hackathon. So ito yung entry namin sa hackathon. Mas pinalit na siya, modified, simpler versions because we know the errors or we know things to improve on our first robotic boy up until now. So again, Aqualoop is a multi-sensor, solar-powered data buoy that collects critical data to address the gap between camera. Yes. Okay na po. Okay. So, yes. So for the Aqualoop, so this is a multi-sensor, solar-powered data buoy that collects critical data to address the gap between the ocean research. Okay, specifically do sa mga researchers, ocean researchers. So we measure the temperature of the water. We also check multiple things: salinity of the water. We also check the area we survey. The area may mga cameras yan. So right now you are wondering how can we're still on the online learning modality because of COVID. And one way to teach our students, our children Arduino for you to expose your children to or students to STEAM education or stream education. So Tinkercad offers, I think, from basic up until intermediate level of interfacing with Arduino. So this has multiple sensors na rin and actuators that they can interface so that the students will still learn and and with a virtual simulator they are kumbaga had the freedom to commit mistakes kasi hindi naman, for example, di naman mag-short circuit yung board, for example, if they connected it incorrectly. Okay, so this is actually a good start for them to learn electronics, circuitry, and Arduino. So one example of that is, for example, we have the MQ2 gas sensor. So with the use of Tinkercad, may interface na nila. They can program it and they can practice getting data, practice the use of Arduino. Yes. Okay.
Okay.
So yun. So as I mentioned a while ago, uh, Arduino in modern day teaching is possible. You just have to have a right curriculum and you just have to have uh, the correct fundamentals for you to implement it. Okay? Modern day teaching promotes interactivity. So dapat interactive yung learning, more on activity-based and project-based. So that at the end of the day, the students will exit our schools with the right skills for them to be prepared for the future jobs. Yun po.
Okay, thank you so much po, sir. Now we can proceed to our questions po, sir. Okay lang po ba? We answer some questions po from our live audience. Okay. So, unang question, sir, sir, may I ask suggestions or ano pong
Yes
pwedeng
po,
mga
yes po.
alternatives, teaching strategies in teaching robotics or Arduinos to student? Kasi kaming mga nasa rural areas are having difficulty in the access of such learning materials or gadgets and they are also expensive.
question, it's actually a challenge as well in our company sa First EduSpec. Some of our clients were in the provinces, and one of the challenges that we are facing right now is the access to internet connection and also with the materials. So what we did is we shifted from online modality, we shifted to modular modality. And on the modular modality, we especially the programming lessons into flowcharting so that kahit papaano uh, the students will have the sense of the algorithm that maaaral pa rin nila that certain, for example, input and output, certain conditions are met, ito yung magiging output, at least, kumbaga yung of it. When it comes to circuit building naman, syempre hindi natin maiwasan yung pag-purchase ng material, especially the Arduino. I have two suggestions. One is some of the or kumbaga you try to package or you try to first draft your curriculum. Ano yung gusto mo matutunan yung mga bata? For example, hindi agad magiging heavy. So for example, uh, you designed it first for them to learn circuit building. Okay, and then for the next year, try naman natin digital programming. And then on the next year, analog programming. So that when you purchase material, hindi yung isang buong starter kit na, you just purchase what is needed for the curriculum. So that's option number one. Option number two, kung hindi talaga kaya mag-purchase, kung may access naman sa internet, you try to use Tinkercad. Kung wala naman internet and then still you want to push through, we go back to the traditional way of para siyang books of them seeing the pictures and how is it connected. So kung creative yung teacher, pwede siyang gumawa nung I remember nung teaching days ko pa, or I mean practice teaching days ko pa, gagawa talaga ng parang replica or diorama, and then you simulate, you can use yarn for it to represent a certain wire, tapos another diorama of a certain component, kasi co-connect mo siya. So parang ganon. So we go back to the traditional, but we make sure that it is interactive. You use representation. Traditional learning pa naman is okay as long as you promote interactiveness to the to the lesson. Next question po. I hope I address your question.
Yan, thank you po, sir. Our next question po, tips on how you do assessment and timelines of the projects. How can it cater for students, or do we have any government collaboration going on po?
With regards to the government collaboration, I think DepEd, as far as I know, is collaborating with different uh, suppliers and also providers that would cater that will let them have this kind of materials injected to their curriculum. Kasi nga, DepEd also acknowledges that we lack innovation when it comes to the materials. Okay? So I think they are, as far as I know, they're doing their best na mag-acquire the material for them to have these kinds of tools for innovative learning. So I think meron namang ganong initiative yung government natin. Second, with regards to the question of timeline with regards to the project and assessment tips, as a teacher for 4 years, siguro yung natutunan ko kasi, especially when I was still teaching on my early days, tas robotics pa, I try to make the students learn a lot with a short amount of time. So, ano nangyayari doon? Nagkakaroon na-overwhelm yung mga students natin. And we don't want that to happen because once they're overwhelmed, yung interest nila sa certain, hindi lang sa robotics, sa other subjects din. Once they are overwhelmed, they tend to lose interest. Once they lose interest, kahit anong motivation ang i-inject mo pa dyan sa student, they will have a hard time learning it. So, you try to face your lessons. So for example, you start off with a simpler topic. So mag-introduce ka muna ng mga simple concepts. And then as a teacher, mag-gauge naman natin yan na okay, na-discuss ko for example lang, temperature. Temperature is something, it's a measurement of hotness and coldness of certain materials and things. And then pag more they want more explanation, then you feed them more information on what is temperature. Let's say sa sensor, you try to analyze first, is this sensor a digital component or an analog component? For me, mas madali ituro kasi yung mga digital sensors. Mga on-off lang naman kasi yan. But when it comes to analog sensors, it requires more explanation. So for example, I am teaching a digital sensor, I can siguro face it for kasama na yung mga assessment and the performance task, siguro mga 5 meetings. The first 2 meetings, more on fundamentals, the concept. The third meeting, try to build the circuit, try to make them engage with the sensor or with the component that you're trying to teach. And then the fourth session, yan, magpa-transfer task na tayo. And then after that transfer task, i-check mo are the students mastered the certain skill sets that you want, kasi kailangan pa nagturo ka meron ka objectives eh. So na-meet ba yung objectives after ng transfer task? If hindi na master, hindi na meet, you go back to certain topics and try to address those concerns. Doon naman sa mga nakatapos na, you provide them a different activity. Kasi we do understand that hindi lahat ng mga students pare-parehas na nasa phase ng learning. So you provide them different activities, advanced activities for those advanced learners. So yun, sa mga difficult sensors or components, try to face them siguro mga 7 meetings or 8 meetings. Mga ganon.
Okay po,
Next
sir.
question po.
For our last question, sir, since karamihan sa kanila nag-thank you na po. Ang last question po, sir, as a beginner for Arduino, what would be the steps to start to integrate this in robotics?
Ayun. So, good question. So, back then, yung nagsisimula rin ako, that was 2016. 2014 to 2015 kasi I'm still teaching robotics pero I'm using Lego Mindstorm and Vex IQ. When I shifted to Arduino, aminin ko nagkaroon ako ng challenge. There was a challenge for me to shift from a modular robotics component into an embedded system, parang motherboard, parang ganon. So I tried to learn first mastery of digital programming. So yun lagi yung inuuna, foundations of circuitry. Next is how to program digital component. And from that situation, na-master mo na yung paggawa ng circuit, na-master mo na yung pag-program ng digital component, then you proceed with analog components. Yan po.
Okay, sir. So, do you have any closing message po for all of our participants? We have 580 viewers, sir. Grabe. Do you have any message to them po?
Yes. So my message to especially some of the viewers, I think, are teachers, based on the questions na receive natin, do not be afraid to integrate Arduino to your curriculum. Uh, do not be afraid to start off small kasi yung iba gusto bongga agad yung magiging project ng mga students natin. So we try to start with small things first, one step at a time. Circuit muna, paano ba pailawin yung LED, and then build your curriculum up until to the most complex project. Arduino is very flexible and very accessible. Medyo ano naman din siya, mura lang naman din siya, and of course meron diyang mga sabihin na natin mga clone copies din na mas mura. Uh, and then once you have your solid foundation, then you proceed with a difficult project. Do not be afraid to start off small. And kagaya nga nasabi ko, if you're still hesitant, try to use the online platform, try to use the Tinkercad kasi it's very helpful na mag-start muna sila sa mga simulator para at least hindi tayo afraid mag-commit ng mga mistakes when it comes to building our circuit. And kaya natin to. Yun lang.
Thank you so much po, sir. And